Yesterday we said we are going to do what's your name? Balancing reactions, but we did one question on isotopes, and I give to a couple of my students, but they said they are finding it difficult to do it. So this is lesson 7. Is it lesson 7, yeah, or lesson 8? You remember? 8, yeah. Okay. So quickly, before I go into balancing equations, I'll just solve one question quickly. Yeah. Question is, in the solution, okay, there is a isotope of calcium, okay, and they are calcium 38, 19, and calcium 19, calcium, and they are in a ratio. They're in a ratio of 5 is to of 4 is to 1. 4 is to 1. Now, in some textbook, they call this abundance. Instead of ratio, they call it percentage of abundance. It is abundance. Okay, it could be in ratio. They could say it is 70% Ca 38 and 30% Ca 40. Okay, either way, either they put ratio or put out that one is the same. So calculate the relative atomic mass. Calculate the relative atomic mass. Okay, and relative atomic RAM is equal to the mass of one of them, yeah, the mass of one isotope, yes, because isotope A times the ratio, okay, times the ratio, plus the mass of the other one, isotope B, times the ratio, divide by the two ratios, yes, ratios 1, 2, okay, 2. It's the same. Just multiplying this one by its ratio, this one by ratio, and find the average in it. The average when you add the 2 in it. Mustafa, I have the question here. I sent it on our Leicester forum, yeah. But people are saying that it's very difficult to deal with it, yes, because maybe they have not done it, or they're confusing this word, their abundance, yes, because in the book, in the AQA book, let me grab it. I think that's the one, the new AQA. In the AQA book, they said they say abundance, yes. They said it is the sum of isotope abundance times the isotope mass divided by the sum of abundance, yes. And the question is, copper has 2 stable isotopes. Copper 63 has an abundance of 69.2%, and copper 65 has abundance of 30%. Find the relative atomic mass. Okay, we can do that as well, so that people don't confuse ratio and abundance. Yes, this is very simple. You multiply the first one, calcium 18, by its abundance or ratio. Okay, if it is ratio, it's going to be 38 times 4 plus the isotope 40 times 1, all divided by 4 plus 1. You see, the mass of the first isotope 1, you can say C1, okay, we call this C2 in it. So C1 and 8 ratio. So we can say CA38 is to CA40 in a ratio of 4:1 in it, or 70%, 30%. Do you see? Yes. That means in the solution, okay, there is 70% of calcium isotope Ca38, but 30% of calcium isotope 40. Okay, so you are just finding the average of the two. You can either say here 38 times 70 plus 40 times 30 divided by 70 plus 30. This is basically the average, isn't it? Okay. Now this one, 48 times this, 48 times 38 times 4, 38 times 4 times 8 is 32, isn't it? Got a 3. 4 times the 12 plus 3, 7, in it. Or 5, in it. How can a mathematician? 4 times 38, 4 times 8, 32. 2 remain carry 3. 4 times 12, 12 plus 3, 15, in it. Plus.
Yeah, it will be 4 times 30. 4 times 30.
Yeah, 4 times 30, which is 120, yeah. Plus 4 times 2, 32, which is 152, in it. You know, this one is 40, in it. 40. Divided by 5. So this is equal to 192 divided by 5, in it. 5 can go into this 3 times, in it. You mean the 4 into 34.4. So the relative atomic mass is 38.4 grams, in it. Yeah, this other one also the same thing. Okay? When you use 70, okay? As you say again, 70 times 30 is 210. 7 times 8 is 56. Then that's 266. So this is 266 plus 7 times this thing will be 120 in it. And then we add zeros here because it's 17 in it. We add zeros because 70 is zeros. So all over 100. So if you add the 2 here, 2660 plus 1200, that will be 6083. So that will be 3860 divided by 100, which is 38.6. So in this solution, if it's that way, in that ratio, it will be 38.494. If it are in that ratio, it will be 38.6. Okay? And this is a very common exam question. Okay? As I said yesterday, when I was doing my own O-level, this was the question there. Where is the? Yeah, but in this question here in the book, it says an isotope of copper. This time copper. Okay? So one is copper 63. They didn't put atomic mass, it doesn't matter, okay? And the other one is copper 65.
Does every element have an isotope?
No, not every isotope. Briefly, I'm going to explain what an isotope is again, okay? And the abundance is, this one is 70%, and this one is 30%. So what is the relative atomic mass? Okay, simple. Same thing. We find the average of the two masses. This will be 63 times 70% plus 65 times 30 all over 70 plus 30, which are the relative abundances. Okay, this is how abundant they are in the compound. Do you get it? Halima, do you get it? Yes. So this is how abundant they are. That's one is 70%, one is 30%. So you multiply both by their respective percentages. Okay, and you find the average. Just like find the average of the two. Okay, so 70 times this. Okay, 70 times what's it again here? 70 times 63. How much would that be? 7 times 60 is 420. And 70, 4,200 because 70 times 70 times 16, 4,200. And 70 times 30, 2001.
No, not 33, 3.
70 times 30, yeah. 70 times 3 is 100, yes?
So is 100, is
210.
10, yeah.
Yeah, 210. Okay? So that will be 0, 1, 4, 4. Okay, so that will be 4410 plus 30 times 60. What is 30 times 60? 1,800 in it. Okay? Then 30 times 5, that will be how much? 150.
Yeah.
So this is 59 to this 1,950 divided by this plus this is 100, isn't it? So basically, it's just like saying divide 18 by quick mathematics, yeah? Just like 44.1 plus 19.5. Quickly, mathematician, how do I get that?
You divide it by 100.
Yeah, but everything by 100, isn't it? If you divide it by 100, 44.1, divided by 19.5, isn't it? So 44.1 plus 19.50. This is 60, this is 3, and this is 6. So it's 63.60 grams. So relative atomic mass of that isotopes of copper is 63.60. Okay? So I'll give you time to. But this is a digression because when I say it in a forum, many people cannot work it out. You understand? So I say, let me solve it. And then the question went on and said, what is the what is the equation of the reactions? Now, quickly, let me show you this. Now, this is my last year notes, okay? And I covered isotopes there. Okay? Okay. Atoms and isotopes. Okay. In that note, I said an isotope is an element with the same atomic number but different mass number. Now we get it, isn't it? An isotope. Okay. Yesterday we did this, isn't it? Yes. It means it's an element with the same atomic number. Okay. Same atomic number, different, okay, mass number. That's what an isotope is. And if you look at this, if they give a question like this, okay, they said you are given 3 compounds, yes? Identify which an isotope. Compound B, 1210. C, 13.6. D, 10.13. Okay? E, 12.14. F, 5.10. Okay? G, 12.15. Now, which of these are isotopes? Bearing that they have the same atomic number, different mass number.
E and G.
Okay? Which one?
E and G, C and D. B, E, and C and D.
Now let's start here. B. B and which one? B and
No, and D.
D. Why?
They have the same.
They all have
10.
10 atomic number in it. Which one? Again.
E and G.
E and G in it. E and G. Because they all have 10.
12 atomic number.
Yeah? This one they all have 10 atomic number. This one they all have 12 atomic number of 12. So they are the isotopes. I think now you understand what isotope means. Same atomic number, different mass number. Okay? Now, and I give an example of relative atomic mass number. Okay? We give carbon. Okay? We give carbon. Mustafa, did you understand this?
Yeah.
Okay. Another question concerning this is example is a compound has 2 isotopes. Has two isotopes of C35 and let me call X35 and X37. Okay? In an abundance of 50% to 4 x35 and 30%, 60%, yeah, of x37, or in a ratio, of 5:3. Okay, what is the relative what is the relative atomic mass number? Same. Okay, we multiply it by its ratio. Okay, 35 times 5 plus 37 times 3 all over 5 plus 3. Because we use the abundance one is, we use the abundance, it will be 35 times 50 plus 37 times 30 over 50 plus 30. Okay? In any way you do it, you come to the same conclusion, yeah? This one, when we do multiplication, we have 175 plus 111 divided by 8, which is equal to 35.75 grams, because they are given grams, yes? Mass number is in grams. Okay? This is another example of isotopes. Okay. Still now we have not gone to do equations. Okay? I think if you are given a question on isotope, you can do it well, yeah? Okay? So, if you have compounds like this, let me finish that one. X 5, 10. Okay? Y 6, 14. Okay? P 6, 15. You see? F 5, 15, 7. Which of them are isotopes?
14, Y and P.
Y and P, okay? Y and P are isotopes. Why?
Because they have the same mass.
They have same atomic number in it. Yes? But different mass number. Okay? Yeah. Mass number. That's all what you mean by isotope. Okay? Different mass number, but the same atomic mass number. Okay?
Yes, sir.
Okay, we'll stop here. We have done isotope. Still, we have not done our equations. That's funny. The reason I did it is when I sent this to our forum, there are some complaints. There are some people have said that they understand. Yes, I sent it to some other students online. They ask a lot of questions. So he said, "What do you mean by ratio?" I said, "Look, you can give it in ratio or in abundance." I realized that in their books they put it in abundance. That's why they're confused by ratio. But if somebody says something is 70% abundant, yes, and 30% abundant, this means they are in a ratio of 7:3. Okay? In either way you do it, same. Come to the same answer. Just like the other question we did, I did not deal with this the other ratio because come to the same answer. Okay? Be careful. It's a question that comes in the exams, and I tell you, I did my own little story about it. Okay, when I did an exam, I found if compulsory question it was this, so I was able to deal with it because it was the our teacher emphasized us knowing this. Okay, now we will leave this to go to the next lesson because even though it become very long, and then very difficult to download it. Yeah. Okay, then thank you very much. Let's go to lesson.